Okay, looking at some modeling problems. Metal Box Manufacturing Company makes metal boxes to house electronic equipment by cutting squares and rectangles from a 10-inch by 20-inch piece of metal as shown. Each box goes through a pneumatic press to bend the rectangular prism in the corners, and they're welded. What is the length y in terms of x? How about the width in terms of x and the height in terms of x? So it wants us to find the length y. So I'm right here beside my length. I'm going to write y over there. If we look at our diagram here, you've got this piece x, and then a y right here, and then another piece x, and then y, which we don't know what the lengths of those are right now, but what we do know is that this x and this x, so those two x's, and this y and this y, so those two y's, are a total length of 20 inches. So let's use that to help us figure out the length. So we can say those two x's plus two y's equal 20. And one of the things I notice about that is they're all divisible by 2. So therefore, x plus y equals 10. So if we solve that for y, we would subtract x from each side, and we get 10. We get y is equal to 10 minus x, which represents the length of our box when we fold it up. And it kind of makes sense if you think about it. If the whole piece is 20, half of it, like if I came right here, half of this is going to be 10, just from there to there. And so if I wanted to know just the length of y, I would have to take the x away from 10 to just have y left. So some of y'all might be able to see it without having to do the little equation above. All right, now let's figure out what is the width of the box. So that's where we're looking at the top part. So if we want to figure out the width, we can see that originally the whole piece right here from beginning to end is 10 inches long. But what they're going to have to do is cut out this x right here and this x right here so they can fold those sides up to make the box. So what we're trying to figure out is what's left over there. What's going to just be this piece? What would represent just this part right here? And since you're going to take x away from each side, that would give us 10 take away 2x. Again, if you need to make a little equation for it, you can, but I think most of us can see it. So then what you have to think about is when you fold this box up and fold it over, how high is that box going to be? And the height of that box is going to be x. So it says write a formula for the volume of the box in terms of x. Well, folks, we know that a rectangular prism has a volume formula of length times width times height. That's how we find the volume of any rectangular prism. So what we're going to do is now substitute those expressions we just found to write this function. So we'd say v of x is equal to 10 minus x times 10 minus 2x times x. And if you wanted to, you could multiply that out and expand it and make it all nice and pretty in standard form, and you would have a cubic function, but you really don't need to do that. So then it goes on to say, what domain makes sense for the problem situation? Explain. All right, well, guys, our domain is x. So x represents the height of this box. So I want to go back over to our diagram. I want you to think about this for a second. If this whole piece from here to here is 10 inches, from there to there, and x is the height of the box, what's the most that we could cut out of each side? So obviously we have to cut more than 0 inches away or we wouldn't have a box. So at least we've got to start with our domain being, greater than 0. That only makes sense. But what's the most you could cut away? Well, I want you to think about it. If you cut 5 inches out this side and 5 inches out from the other side, you would have cut away all the way to the middle, and then you would have no width left. So from just thinking about that, that makes sense that our height of our box has to be somewhere between 0 and 5 inches. We can also write that in interval notation. So we can say from 0 to 5 inches, or you might want to write it in words, between 0 and 5 inches, but obviously not including either one, because if you actually make it 0, you're going to have no height, and if you make it 5 inches, you're going to cut all the way to the middle, and you're going to have no width. All right, so then it says sketch and label a graph of the volume function over this domain. So for this part, you can use your graphing calculator. So we would just type our function into y equals. And then I would start by going to the table to see what kind of values we're looking at. Since we already thought about this, we know that even though this is going to graph a beautiful cubic function, we have to think about what this function represents. X represents the height of the function, and v of x represents the volume of the function. So we don't want a negative volume, and we don't want a negative height, because that just doesn't make sense in the context of the problem. So there's no reason to look at these negative numbers. And then when we start looking from 0, obviously we talked about if we made the height 0, we'd have 0 volume, because it would just be a flat rectangle. And then if we went up to where we cut into 5, it would go back to 0 volume because we would have cut too much away. So this kind of gives you the part of the function that we need to use for the context of the problem. Anything before 0 and anything after 5 just doesn't make sense. This also helps me to figure out my window. So when I go to set up my window, my x values are fine. If you want to not see so much and kind of zoom in on it, you could change your x min to like -2. And you could change your x max to like, I don't know, 7, so that you really are closing in on that between 0 and 5. But we definitely need to change our y max because we can see that went all the way up to 96. So you might want to put a little buffer on that. I'm going to make mine go to 110 and have my y scale at 10. And then we'll graph it. We see that pretty curve. And we're going to put that on our paper. Make sure you label your x. So this actually is just a piece of that cubic function. So I'm only graphing the part that makes sense for the domain from 0 to 5. Notice I've labeled my x-axis as my height and my y-axis as my volume. So the next question says, use the graphing calculator to find the maximum volume of the box. So go ahead and pause the video and try that. So recall, all we have to do is hit second, trace, which is our calculate. We're going to go to maximum. And then we're going to go a little to the left of that maximum point, press enter, a little to the right of that maximum point, press enter, and if you want to guess, you can, and it gives us our max. So let's write that down on our graph on our paper, and also let's make sure that we answer the question. So we get that that's 2.113, 96.225. You may just for your own purposes just remember that this represents x and this represents v of x. So then it goes on to say, what are the dimensions of the box with a maximum volume, and what is that maximum volume? So to answer that question, what we now have to do is take this x value and we have to substitute it back into our expressions for the length and the width and the height. So I'm pretty much just substituting right here. I'm saying 10 minus 2.113, and then 10 minus 2 times 2.113, and obviously the height would just be x. So you would go ahead and calculate that, and when we do, we should get that the dimensions would be, for the length, the dimension would be 7.887 inches. For the width, we should get 5.774 inches. And the height would be just the 2.113 inches. And then what is that maximum volume? The maximum volume is the 96.225, and we make sure we say cubic inches because it represents volume. 96.225 cubic inches. All right, so then it goes on to say, metal box manufacturer would like to create boxes of different volumes from the same 10-inch by 20-inch piece of metal. The volume must be at least 72 cubic inches. Write an inequality for the volume that satisfies the constraint above. So guys, we already have our volume formula, so all we're going to do is we're going to say 10 minus x times 10 minus 2x times x must be greater than or equal to 72. Now, if we were working this out algebraically, we'd have to multiply all that out, subtract 72 over, set it back equal to 0, and then use these algebraic techniques like we learned the day before to solve it. But for this lesson, you can use your technology, and I want y'all to see how you would solve this using technology. So we're going to go back to our graphing calculators. We're going to go to y equals, and we're going to come down to y sub 2, and we're going to type in 72. And then we're going to go back to our graph. So what we want to do is we want to find the intersections of this horizontal line at 72 and our curve that represents our volume. So remember to do that, we hit second, trace, we're going to go to intersect, but because there's more than one intersection, what we have to do is we have to take our cursor and we have to scroll over, and I try to get like right on top of one of the intersections, and then when you do, you're going to press enter, 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 so that it knows that's the one you want. And we can see that one of those intersections are at 172. And then you do the same thing again, you press second, trace, you do intersect, but this time we scroll over, sorry y'all, I know that. Scroll over by it, and then again, press enter 3 times so it knows which intersection we want. And we're going to write that down. So let's go put that on our paper. So we know one of these occurs when x is 1, and we know that the other one occurs when x is equal to 3.394. All right, so then we're going to answer our question. And it's, remember, it says so that it's larger than 72 cubic inches. So if we want the volume to be larger than that, and this is a little bit tricky because over here it said it must be at least, so actually it should be greater than or equal to 72 inches because of that at least word right there. So to answer that question, we would say, therefore, our height of our box needs to be between 1 and 3.394 inches. And if you want to write it in interval notation, that's fine also. All right, so now try the practice problems, numbers 1 and 2.